This one is not going to be easy, just because it requires a lot of focus and a lot of time. We can use the double angle identity to say that, well, let me write the double angle identity down. We'll say 2u is equal to 2 times the sine of u cosine u. This is one of our ones that we memorize. So we're going to use that, and we're going to say sine of 6x is equal to 2 times, and I'm allowed to say half the angle now. So sine of 3x times the cosine of 3x. And that's a good start. Now, we can't remember that we're waiting on that part, okay? So we'll come back to that. But in the meantime, we're going to get distracted by this other here. And sine of 3x, if you recall, we have sine of u plus v is equal to the sine of u. These are called the sum and difference formulas, and we're just going to use the ones that are the sums. Oops, I was going to put sine. Sine's not like that. Sine let cosine come in here first, and then it lets cosine have a first turn, if you remember. And cosine is not so generous, or gracious, I should say, either way. Cosine has both turns first, and it changes the sign. So I wish I had a different word for that, but anyway, the sign of the equation. Okay, so that's what we have, and that's what we're going to do. We're going to say 2 times this whole thing, and the sine of 3x is going to be, well, let me write it out like this. Sine of 2x plus x, okay, because I can't have that. I could cut it in half, but then I'd have 3.5, and that's no good. So I know there's a formula that does that for me. What's it called? Anyway, there's a formula that would do that for me. And I'd do the same thing again. I'd use the double angle formula, but then I'd have to deal with 3 over 2x, and I don't want to do that. So I also have cosine of the same thing, 2x plus x. Okay, so let's do that. We will say 2 times the sine of 2x plus x, and I'm going to use this up here, okay? So I'm going to say that is the sine of the first one, sine of 2x, times the cosine of the second one, plus the cosine of the first one times the sine of the second one. Okay, that one right there. And then, okay, so I better put that in parentheses. Times the cosine of 2x plus x, okay, and now I'm going to use this one down here, okay, and that's going to look like this. The cosine of 2x times the cosine of x minus the sine of 2x, the sine of x. Okay. Now, I suppose we could go about this in different ways, but and we might be able to find something that worked out well. But I'm just going to go ahead and use the double angle formula again. And so I'm going to say this may be overkill. Maybe you can think of a better way. But instead of saying sine 2x, I'm going back to this one. Okay, excuse me for that craziness, but so let's see. I have 2 sine of x cosine x times cosine x plus, need parentheses because I'm going to say cosine squared x minus sine squared x. That's another one of the ones that we use a lot. And I suppose I should write that out. If I put this up here, I guess I should also say the cosine of 2u is equal to cosine squared u minus sine squared u. Okay, so that's what we're using there. And that's the one we remember. I know there's 2 other versions, and maybe they'd be more helpful. I suppose they would, but we can only remember so much. I'm on parentheses here. And then times, is it times? Yes. Times cosine 2x, well, that's cosine 2 squared x minus sine squared x. This times the cosine x minus, again, I have 2 sine x, cosine x, and then the sine x comes in there. And so that's good there, and there's my bracket. Alright, so now what can we do? Well, let's clean this up a little bit. We'll say 2, and we'll say 2 sine x. I'm going to keep my sine x first if I can. Cosine squared x plus, you know what, in the meantime, kind of in between here, I don't want to have sine to the third power. So I'm going to change the parentheses to cosine squared x minus 1 plus cosine squared x. And you say, how can you do that? Well, I hope you remember, I really, really hope you remember that sine squared x plus cosine squared x is equal to 1. That's the granddaddy of them all right there, so don't forget that. And I just solved for sine, I solved for sine squared x, so if I were going to do that, and let me just show you right here since I skipped it, is equal to 1 minus cosine squared x. And that's what I fed in there, except that I was subtracting it, so I had to change the signs. Okay, I subtracted it, so I had to change the signs. So now instead of being a plus 1, it's a negative 1. Instead of being a minus cosine squared x, it's plus cosine squared x. And it's still times sine x, okay? So when I write it down here, I'm going to say, what am I going to say? I'm going to say, oh, there's 2 of these cosine squared x's, right? So I'm going to say 2 sine x times cosine squared x, and then I get a minus sine x when I distribute. So I put these together. Sorry about that. I skipped another step. 2 of the cosine squared x's. So I get to say 2 sine x cosine squared x, and there's 1 sine x. Okay, so that takes care of that. And then I guess I'll switch to brackets for the second part. I'm going to do the same thing over here. I'm going to say, I don't want to get a cosine times cosine squared, because that's going to give me cosine to the third, and it's just another headache. I mean, I could deal with it, but let's just do this. We'll say, instead of cosine squared, we'll say 1 minus sine squared, right? And then we'll say minus sine squared x. Okay, so what that does then, as I put these together, it gives me a minus 2 sine squared x. So I'm going to say cosine times 1, so I get cosine. Oh, back to my blue here. I'm going to say cosine times 1 is cosine x. And then cosine times 2, negative 2, sine squared x. I still get my cosine. Minus, what's happening over here? 2, there's 2 of the sines, so I get sine squared x cosine x. Okay, alright, so we can further simplify now. We can say 2 times, there's 2 of these 2 sine x cosine squared x. So I'm going to say 4 sine x cosine squared x minus sine x. And then again I have 2 of these guys, so now I have minus 4. So I'm going to say cosine x minus 4 sine squared x cosine x. Okay, now I notice I can factor out something here, and I'm going to. I can factor out a sine from the first 2, so I can say 2 sine x. And from the next brackets, both of them have a cosine, so I'm going to factor out a cosine. Everything's being multiplied together, so I can do this. And what's left? Well, I have 4 sine Oh, I was going to say sine, but I took the sine out. Okay, sorry. No sine left. And so I just have 4 cosine squared x minus 1. The sine is gone. I took out the cosine, so 1 minus 4 sine squared x. Cosine is gone. And at this time, since it looks like we could solve each part for 0, it is time to remember something. It is time to remember that we skipped the sine of 2x for later. So instead of writing the sine of 2x, I'm going to use this double angle formula, and I'm going to write it as 2 sine x cosine x, okay? Because I still have that, it's still there. So I'm going to say plus this old thing, 2 sine x cosine x. The first time I did this problem, I forgot that I had skipped that. And I was like, what's going on? There's always something going on if you forget what you're doing. And we want this to be 0, right? Well, I don't know. I hope that you can see that I can take out both these guys to the front, so I'm going to do that. And I'm going to say 2 sine x cosine x times, well, let's see, what's left? I have these guys that I'm going to have to multiply together. I was kind of hoping I wouldn't have to, but you know, I'm going to have to. And I guess I'll put this in parentheses. Boy, that doesn't look quite right, does it? Use a bigger bracket. No, I'll just do this. And oops, not yet. I have this 1 over here now that I factored out that. Okay, so I have this 1. Alright, so that means I have to multiply the binomials together. Alright, so I have 2 sine x cosine x, but don't worry, it works out. I have 4 cosine squared x. And then let's see, I get negative 16, I forgot my square, sine squared x, cosine squared x, minus 1, and then plus 4 sine squared x, and oh yeah, here at the end inside my parentheses I got that one. So I'm going to say plus 1. Alright, now these 1's cancel, gone. Okay? And let's see what happens next. What happens next is I can take a 4 out of everything, so I'm going to do that, and I'm going to say 8 now in front, as I took an extra 4 out. Okay, the 4's gone, so I have cosine squared x, minus 4's gone, so I have 4 left over, sine squared x cosine squared x, plus sine squared x, and isn't that pretty? Back to the granddaddy here. I can turn that into a 1. So my factoring days are now over. I can just write this like this: the sine of x cosine of x times 1 minus 4 sine, well, they're almost over, pretty much over. As far as I'm concerned, they're over. Okay, so there we go. Because I can use that Pythagorean theorem, or identity. Alright, so now I have 3 situations for this to be equal to 0. When is sine x equal to 0? Well, that's not too hard. X would have to be equal to 0 or pi. Okay. When is cosine x equal to 0? Well, x would have to be equal to pi over 2 or 3 pi over 2. That would get the job done. And then finally, when is 1... Can I just move that over and just say equals to 1? Let me say that. Let me say, I set this equal to 0. Maybe I shouldn't do that. For purposes of clarity, let me just go ahead and say this. That's equal to 0. So therefore, when I move it to the other side, I'm going to say that sine squared x cosine squared x is equal to 1/4, right? When I do the algebra, and I get the, I move the negative to the other side so it's positive, and then I divide both sides by 4. And then I take the square root of both sides, and I'm going to say the sine of x times the cosine of x is equal to plus or minus 1 over the square root of 2. Well, that's my, let me just do quadrant 1 here. That's my 45-degree angle. That's pi over 4 right there. Okay, so what are my solutions? Well, x would equal, x would, let me see here, let me see. X would equal, yeah, if I squared it, that's what I want, because then I'd get 1/4, then I'd get 0. Yeah, okay, I just had to convince myself that that was true. Pi over 4, it's plus or minus, so I can also have 3 pi over 4, 5 pi over 4, and 7 pi over 4. I'm allowed to go up to, but not including 2 pi. From 0 including 2 pi, to including 0 inclusive, to 2 pi not inclusive. Okay. So these are my zeros, and as I graphed it, I saw that that was the case. So let me put the graph in here to show what we got here. And the graph says we're okay. Or at least the graph makes it seem like we're okay. Oops. So there's the graph. You can see 0, pi over 4, pi over 2, 3 pi over 4 is pi, 5 pi. They're all there. They're all there. Okay. And so we're pretty happy about that.